Yo, everybody, 2022 Physics AS Unit 1, question 6. This is our SUVATs and projectiles question, basically. Let's have a look. Velocity time graph. And it says, using the graph, show clearly that. So you can see there, that's the SUVAT, S equals UT plus a half AT squared. They've obviously used X instead of S. There's no need to freak out about that. The displacement of a velocity time graph is the area under the graph. That there is a trapezium, where the one parallel side is 0 to U, the other parallel side is 0 to V, and the distance between them is 0 to T. Right, so the area of that trapezium, add up the parallel sides, U plus V, half it, times by the distance between them. Now that doesn't quite get us to that equation there. But as you can see in this equation, there's no letter V. So we know the SUVAT V equals U plus AT. So we're going to swap that V there for U plus AT to give us a half U plus AT, which is a half of 2U plus AT, all times by T. The half and this 2 cancel. U times T is UT. AT times T is AT squared, and there's the half in front of it. Job done for 3 marks, okay? That's something you can just practice and learn off by heart, right? You should be able to derive all the SUVATs. On to the projectiles question. So don't forget, they could ask us about the maximum height, about the range. Key factors are, if that's my velocity, then in the horizontal direction, it would be 11 cos 50, and that will not change throughout the time of flight, assuming there's no air resistance. The vertical component of velocity will be 11 sine 50. At the top of the flight, that will be equal to 0. Now, if this was a golf ball question and the ball was on the floor, we could use that top of the flight to get the time, double it to get the time of flight, and then use distance is speed times time horizontally to get the range. This is slightly trickier if they ask us for that, because it's not a fully symmetrical parabolic curve. Let's see what they say. It says, show that the vertical component is approximately 8. So as I just said, the vertical component will be 11 times sine 50. Chuck that in your calculator, it comes out 8.4. It says, hence, so that's using that, right? Using that answer there, the vertical component of velocity. Calculate the vertical distance above the ground from which the shot was thrown. So vertical distance is just the same as saying vertical displacement, right? So again, it's utilizing the formula they gave us earlier. It's always interconnected on these papers. Hence means use that 8.4 there for U. T, they've told us, is 1.95. Gravity is always 9.81. Chuck a minus in front of it because initially that shot put is going up and gravity is acting against it. Chuck those numbers in the calculator, press some buttons, and it comes out as 2.27 meters. Now, I always say to you in class, how do you feel about that answer? 2.27 meters for the shot put, you're thinking, oh, that means he's a very tall guy. But don't forget, the question said from when the shot was released. And if you look at the diagram, the shot put is released, above his head. So 2.27 for that amount there is absolutely reasonable. Let's assume he's about 2 meters tall and there's another 30 odd centimeters of his arm above his head. Absolutely fine. Calculate the horizontal distance. Well, that's simple. The horizontal velocity is 11 cos 50. That doesn't change because there's no air resistance. It's in the air for 1.95 seconds. Distance is speed times time. Times it together, 13.8 meters. And then the last bit, throwing the shot at an angle greater than 50 to the horizontal will increase the horizontal distance because the time of flight will increase. Is that a good idea? Well, I'll prove to you in year 13 why 45 degrees is the optimum angle for maximum range. If you increase the angle above 45, yes, you will increase the time of flight. But of course you will decrease, because think of your cos graph, you will decrease the horizontal component of velocity. And as horizontal distance is the horizontal speed times time, that horizontal distance will decrease as well. So it's not a good idea, even though the time of flight will increase, the actual range of the projectile will decrease. Right? Not a bad projectiles question. I hope you agree. Bye-bye.